Okay, hi everyone. My name's Garston. I'm a postdoc at the University of Newcastle, but this is some work that I did in my PhD with Amy Lee and Ben Newell. And a lot of my work was looking at how do people use particular algorithmic tools. So we might be all familiar with the Netflix recommender system, I guess. You're sitting at home, you want to find out what you want to watch tonight. But I suppose there are sort of more consequential examples I can think of too. Imagine that your job was to be a cybersecurity analyst and you've got way too many ingress points to check for yourself. So you might use an algorithmic tool to help you sort of scan potential infiltrators from innocuous events, for instance. And what I was looking at in this project is how do people build trust in these tools? And what's the sort of information that might affect that sort of trust? So at least for me personally, one thing that matters a lot is sort of understanding how this tool works. So might an explanation about how it might be beneficial, sort of impact the level of trust I might have. And the other thing that might really be important is understanding that's actually better than an existing thing that I could use. So maybe if I told you that it's better than what a person might do, that might impact the level of trust that you have. So I want to go through both of these in this talk, starting with the explanations. You might imagine that movie recommendation scenario that I started with. Suppose you're sitting there at night and you get the information that this algorithm is better at recommending good movies to you. Now, perhaps you might want to know why that's the case. And so one question we got interested in is, might more complex or more elaborate explanations encourage people to have higher levels of trust in the tool that they've been given? So later on, I'll show you some experiments where we compare a sort of simple one-step explanation compared to something that's a bit more elaborate that requires you to think a bit more about, oh, it might have several steps involved. The other aspect might be performance comparison information. And so just in this space, Costello ran a study in which, unsurprisingly, they found that giving people performance information improved levels of trust. So what I mean by performance information is a direct statement that the algorithm for this task outperformed a person doing this task by X%, for instance. And so what that study looked like was this between subjects sort of setup. So in the baseline condition, participants make a rating to the question, who would you trust more to recommend you a good movie? Or the text will be much larger. But it's on this scale, right? Between 0 and 100, and you're picking between a person or an algorithm with the midpoint marked out as, I don't mind either. They had another condition that got some extra information before they made this rating. So in that condition, they're given this statement that in essence can be summed up as an algorithm in this task performs 20% better. And so what they do is compare these two conditions, and unsurprisingly, the information condition has slightly higher trust ratings than the baseline condition. But in this setup, you're talking about two different groups of people. And so the question that we became interested in is, well, how does this specific piece of information influence people's trust? And how might that convince them that this might be a better tool to use? And so what we ended up doing is a bit of a within subjects design following this similar sort of structure where we get people to make initial ratings and final ratings and see how the specific bit of information we're giving them impacts their level of trust. So Costello did pull out a few different scenarios across a range of different everyday sort of circumstances. So you've got a movie scenario, a joke telling scenario, automated driving, and medical treatment. But in essence, in each of these, they found these papers and then they would give this statement. Academics had done this study and they'd shown that the algorithm was better by some percent. So what we became interested in was, well, might the degree of superiority be the important factor here? Might people finding out that it's 20% more accurate matter a bit more than finding out that it's 7% more accurate? The other question, and so what we did with that was we had a manipulation that I'll show you a bit later where we double those percentages to try exaggerate the difference between human and algorithmic performance. The other question we became interested in was, might understanding why the algorithm is better make a difference? And might that be interesting across the different scenarios? And so we'll show you some data by the scenarios separated a bit later on. So just to be clear about the design of the experiments, we've got participants making an initial rating on this scale. They then get some sort of information. So that's a performance explanation. They make a final rating. The question specifically is, who would you trust to provide a good movie recommendation for this movie scenario? The performance information that they're given is this very bland statement. In a recent academic study, professional academics found that a movie recommendation algorithm predicted movie enjoyment with 20% more accuracy, right? The 20% being the core part that we manipulate. And then they provide a final rating with the slider at the point in which they left off after their initial rating. So experiment one's got this performance information with this 2 times better versus 1 times better. And that looks like that. And for experiment 2, we look at the explanations. So like I said, we had a simple explanation compared to a more complex explanation that had a bit more depth or richness to it. We used these 4 scenarios that I outlined before. And just to show you where the talk is going, I'm going to show you 4 experiments, but I'll focus on 3 for the time being. Experiment 1's performance information. Experiment 2 is the explanation. And experiment 3, we manipulate the order of that. So whether providing 1 bit is more influential than the other. And those are all, between subjects manipulations. Within subjects, we have the scenarios themselves. So each person sees 4 scenarios and makes ratings for each. And then the ratings themselves are the other within subjects measure, right? You make an initial rating and then a final rating after you've seen the information. So I'll show you the data for experiment 1 and 2 first. Experiment 1, we're looking at performance information. And I'll show you the conditions separately, but the patterns all seem to really hold across all the different conditions. So what we're looking at here is a change in trust score. So that's calculated from taking the final rating, subtracting the initial rating to see which direction they move in. The different colors represent the different scenarios, and that I've got means and standard errors and the dots and yada, yada, and those are box plots behind them. And I guess the first thing that I noticed is that there seem to be meaningful differences across the scenarios. I don't want to focus too much on those. If you want to ask me a question, I can show you how those differed at the baseline level. But in terms of the change scores, it's worth noting that all the change scores are positive, right? It could have been negative in the sense that you could trust it less given the information. But I think there's something meaningful here in that all the scores move upwards across the different scenarios. So this is the 1 times better condition, right? This is whatever the study found, that's the number that we used. When we doubled those numbers, it didn't seem to make too much of a difference, or the scores were positive again. And so we can say that there's no meaningful difference from that doubling percentage, but the mean trust ratings were all increased. So everyone trusted the algorithm more. When we turn to experiment 2 with the explanations, the single step and multi-step didn't do too much. They all moved positively, they all moved up, but didn't seem like the richness of the explanation seemed to increase the trust scores any more than being provided with a baseline one. So as an interim, we've got this algorithm information seems to increase ratings of trust, at least numerically, the way that we have them. One thing that we got curious about is whether combining that information made a difference. So might being given 2 sets of information seemingly increase your ratings even more than what you get with just 1. And I had a hypothesis that explanations would actually be more useful than the raw percentage improvement itself. So that's my intuition that being told how it works and being told why it's better gives me a lot more space to kind of flesh out, oh, that's why I actually want to use it, than saying it's 7% better without knowing what better means. So I would have thought that the explained first group would have a smaller change in trust because the explanation does all the hard work. So just to be clear about the design, it's final rating, so the initial rating, then final rating, so you get 2 different bits of information. We did pick the baseline performance and the complex explanation, if that matters. But seemingly in the data, the ordering did not seem to have too much of an impact. Generally speaking, ratings went up. Baseline ratings were slightly higher in this experiment, but I can talk more about that later. So one thing to note is that in this particular experiment, there were a lot more people who didn't move their scores. So their scores were seemingly at 0. And you can see that from the medians, which are actually at the axis on these box plots. But the mean ratings seem to go up. So that sort of distinction got me thinking, we have numerical evidence of increases in trust ratings. But what does that really mean, right? I got thinking, well, does it make a difference of a trust rating of 54 to 56, given that the scale of trust itself is a bit ambiguous for what you might interpret out of it? So I went looking for other ways to try index what a meaningful change in trust would look like. One of the things I got thinking was, might the overall preference, might that be something that's interesting? So that could be something like, if you started on one half of the scale, let's say you had an initial preference for the human agent, and then after you got given the information, you moved towards the other half of the scale, crossing the midpoint seems to be a meaningful change that a numerical difference might not represent. So taking this analogy, right, you can think about this bar the way I've got it here and turn it vertically, right? So this is a Sankey plot for engineers, I guess. The plot has in the first bar, and I want you just to focus on that, the initial rating and the people's overall preferences. So this is some 450 people for the car scenario. And what that first bar tells us is that there are more people who prefer a human driver to an automated driving system, and that there's some people who don't mind either. If you then look at the second bar, right, the second bar then says, well, of that group, those proportions have now changed. And now there are more people there are roughly equal numbers of people who prefer an algorithmic system to a human driver. So an interesting question might be, well, where do they start from and where do they go? So what we can see here from the red ribbon in between is that 97% of people who preferred the algorithmic agent stayed the same. Unsurprising, we gave them more information for something they already preferred. What is interesting is if you look at the human preference, 72% of people that started preferring the human had then subsequently retained their preference, which tells me that 28% of people changed. So you can really look at this plot as this middle section here are the group of people who have changed their minds in some meaningful way, at least on the use of that scale. So one question we had was, might there be a way to increase this proportion? And so we went back and thought about the task structure that we had so far. We've got this experiment where participants make make a rating, then get information, then change their rating. So they do this 4 times across 4 different scenarios. So what we get is a very wide, but very not deep, shallow understanding of what people's trust or what constitutes a change in trust for each different situation. So that got us thinking, well, might we be able to give people more opportunities and subsequently more information to perhaps flesh out what they believe or what they think? And might the information we give them actually address the concerns they might have about trusting algorithmic systems? So in that sort of version where you go really deep on just a single topic area, so in this case, the automated driving systems, might telling them that it's safer by a certain percent be meaningful, and then they would make a rating and then subsequently telling them why it's safer and why it's better. But then ending up on, well, there are trade-offs. It's not always better. There are these situations where it's not great. Might that sort of setup help provide more information about people's true preferences, about their trust in algorithmic systems? So I've said that, and I'm going to show you some data a setup for experiment 4. So experiment 4 uses this multi-information, multi-rating setup. There are 3 parcels of information, and we have a large N because there's 6 different orderings that you can present 3 bits of information in. And our hypothesis when we started was that, well, might the trade-off information be actually something that really weighs heavily in your mind? Might being told that, you know, automated driving systems have trouble tracking kangaroos because they jump all over the place, so it's bad for kangaroos in the middle of Australia. Might that weigh on your mind when you're making a choice to rely on one system or the other? So that's that in words. So I'll show you some data. Now, there are 2 different ways that you can look at this data in terms of what information you received and what order that you receive that information in. I'll try to show you both very quickly. This is the information that you received. So again, change in trust scores. How much did it increase or decrease, relatively speaking? And if I tell you things about its benefits, and if I tell you things about it, so why it's better and that it's better, trust scores go up. But if I show you that it's bad for some reason, trust scores generally go down. And across those different orderings, those are the bars I'm showing you there. But if we look at the order itself, in terms of when did people get that information, getting the trade-off information first sort of plummets off those trust ratings. But what's interesting is it doesn't seem to hold across to the end of the task. By the end, when everyone has the same information, at least in the medians, people seem to have similar levels of trust ratings. If we look at this preference sort of idea again, we can break that down by where do people stick with their preferences and where that ended up. But in the interest of time, I might just push ahead. So just to summarize, we've got 4 experiments in which we show that providing information increases numeric trust scores, but the preferences seem to tell a different story, that you need to really work hard to try to address individual concerns. So might that have something to do with trying to figure out what information people specifically find most convincing. So there could be individual level factors, and we're looking into some scales about knowledge and about general awareness of algorithms. There's cultural information here as well, that how is it that Netflix is now something we accept, or that automated driving systems is something that will be in the near future? That's sort of meant to change progressively over time. And so what are the informational factors that you could, well, I guess depending on who you are, if you're a user, you might want to have specific things addressed. If you're a designer, you might want to be conscious of those things when you communicate what sort of product you have to an audience. And finally, might direct experiences with the algorithm itself be quite important? Might the fact that you have good or bad experiences, if you get bad Amazon recommendations, you might turn off from those forever. So I've got some more work in the more experiential domain with some lovely people at UNSW. And speaking of, thank you to these people, and thank you for your attention.